We cared about getting 4 overall. So that's why all 36 outcomes, and there were 3 4s. That one, and that one. We still care about those, right? Those would be greens. Those would be greens. We want that, and we want that. If we roll a snake eyes, so suppose we roll 4. That's our point, right? If we roll snake eyes, does that even really count in the calculation? Or is that just like a wasted roll? It's a wasted roll, right? So we can ignore that one completely. That's not even part of the calculation because it doesn't mean anything. It's almost like we need a new set of dice without snake eyes on it, but we can't do that because Vegas wouldn't let you do that. How about these guys? They mean anything? No. They mean something on the first roll, but not anymore. How about these guys? No. That doesn't mean anything, right? No. Oops. No, 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 no. How about these guys here? No. 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 Oops. No. No, no, no. How about this guy?
Yes.
Oh, he's important, isn't he? He's important. We definitely care about them, yes? We don't want that. Nor do we want that. Nor do we want that, or that, or that, or that. But we have to account for them in the likelihood, don't we? Because that's the bad. Remember, if you're either going to win or you're going to lose. That's going to make you win, and that's going to make you lose in this particular point. How about all these guys over here?
No.
They don't mean squat, do they? They mean nothing anymore. These are meaningless for the point rolls. So how many total rolls are we actually interested in with a point value of 4? 9. There are 9 of them, yes? Of which 3 are wins and 6 are losses. So once you've established your point, you're actually more likely to win on that point than you were rolling it originally because it's like the dice get limited in what they can actually roll. That's mathematically genius. So that becomes 3 9s. And those 6 7s are always going to be in the calculation. So my next question is, going back over here to our distribution, wouldn't that also be the exact same calculation for this guy down here? Because there are 3 10s and the 6 7s, so this once again becomes 3 9s. What would this one be?
4.
Say that again.
4 10s.
How about 4 10ths? Because there are 4 ways to get 5, yes? So we're looking at boom, 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 boom. Now we don't care about the 4s anymore, they're done. But we do care about 4 ways to get 5, but still 6 ways to get 7, yes? So it's going to be 4 10ths here, yes? Who else is 4 10ths? Down here 9? Oh, yes. And how about 6? 5 11ths. 5 11ths, which is also this guy over here, isn't he? With me so far? Everybody buying this? Now, here is the part 2 of the genius calculation. What's the chance of rolling the 4 and then rolling the 4 again before you roll a 7? What do you have to do to these 2 numbers? What do you think? What are the 2 gut feelings you're getting? I heard add. Boom. There's add. Another vote would be multiply. Good. Those are the 2 guts. And this is a great question. This is a great question mathematically. Is what do we do logically? Multiply or add? Give me a rationale for add. Give me a rationale for add.
Aren't they connected to each other?
They definitely are connected to each other.
Yeah.
So Jacob, what are you leaning towards right now?
Well, I said add just because what you had been talking
No
about.
problem.
But
Watch this. Here's why we can't add. What's 3 9ths? It's a third, right? 33%. What's 4 10ths? 2 5ths or 40%. 5 11ths is about 44%, I think. If you add 30%, 33% plus 33%, that's 67%-ish. Plus 40% is now over 100%, 140%, basically 200%, plus what's over here is going to go way, way, way over 200%. Is Vegas going to pay you 200% of the time? That's like them, when you walk through the door, them handing you money. Then you walk up to the table, they hand you money again. And they say, don't even bother playing, just take my money and go to hell home. That's not going to happen, is it? Now that's a mathematical kind of, that's a proof by contradiction as to why we can't add them. Now prove to me why we have to multiply.
You have on the first roll, you have that 356 that percentage, and then you have to give that percent of that. It's just like when you
It's
like
just like with,
sale, like
it's just like a sale amount when you're taking percentages of percentages.
yeah.
It's exactly what it is. I thought you were going somewhere else. It's just like the chickens. It's like the roosters and the chickens again. In order for me to get 2 girls, I first have to get a girl and then I have to get another girl, which means I have to first get lucky enough to land in 90%. Then after that 90% of the time, 90% of that 90% of the time, I need to land in the girl-girl category. So it goes back to the word of, from mathematics that you learned back when you were teeny tiny. Of means to multiply. So in order to hit 4 and then hit 4 again before rolling a 7, you first have to get, just like you said, Aaron, just like you said, you have to get in this 336, which I think is about 8%, roughly 8%. That's 8%. And then, if you've gotten that 8% of the time, 1/3 of that 8% of the time, you're going to follow with a second 4. So yeah, you have to multiply because there's a word for that percentage on sale thing, and I can't remember what it is, like combined percentages or something. But it really is like the word of in mathematics. You remember what it is? I forget what it is. The idea of a sale, I love the idea of a sale though, like combining percentages. I just got to use it the other day to explain to somebody, kind of, compounding percentages, sure. I was explaining to somebody why, there was a spoof on Instagram about 2 days ago. This guy called Real Todd Michaels. Hi, I saw your Instagram account. He claimed to have won the $34 million California Powerball. And he said, if you follow my Instagram account, the first 10,000 people that follow my Instagram account, I will PayPal you $1,000. And all my friends from back east were just jumping all over this, and I'm like, careful guys, it's a scam. It's like, how can it be a scam? And I'm like, well, if 10,000 people are each being paid $1,000, that's $10 million right there. So that's 1/3 of his winnings. He's already lost, I'm assuming this guy's legit, which it turns out he wasn't, surprised. He's already lost half, more than half of that value to the Powerball lottery for taking it as a lump sum. You get roughly 40% of your winnings. So he's only going to get about 11 million of that, and that's before taxes. Then he's got to pay taxes, which is, I think, is around 30% of that. So now it was, what did I say, 10 million? Now he's down to about 7 million, but he's promising to give away 10 million. And you should have seen some of the responses. This is witchcraft! I'm like, no, this is mathematics. This is multiplication. But it's that idea, it's that applying the percentages across the board. Thank you, Aaron, for eloquently saying it.
Will you say it again? No,
Yes!
sorry.
So in order for us to fall into this category, we first have to roll a 4, which only happens roughly 8% of, this is about 8% of the time. Then, once we're in that 8%, we have to roll, again, only 1/3 of the time, a second 4. So in order to, we're traveling down the branches of your tree, if you think about it that way. We're traveling down the branches of your tree. We first have to multiply this guy times this guy to stay on that branch. So the probability, whatever, I'm going to need your guys' help with the decimals on this one. Whatever this probability ends up being, the probability of winning on the point is going to be 3 and 36 times 3 9s. Let me make this a little bit easier. We can go 1, 3, 1, 12. That's 1 in 36. Oh, that's actually not that bad. 1 in 36. That comes to about 3%-ish, somewhere in there. 2.7, 2.8. 2.7 and some change. Good. Did I do that right? Did I cancel everything right? I think I did. Hey, guess what? That's also the chance of winning on the 10, isn't it? So if you think about it, if you want to think about this mathematically, that's just like rolling snake eyes on the first roll, isn't it? Or boxcars, for that matter. Remember how unlikely it was to roll snake eyes? It's just as likely to win on 4 on the points. Pretty slick, huh? Pretty cool, pretty cool, pretty cool. How about this one? 436 followed by 4/10. Similar argument, yes? Similar exact, I like Aaron's argument. I'm going to change colors so we can kind of keep them separated here. This is 4 and 36 times 4/10. That's a 6. That goes to 9, right? That's a 1, it's a 2, and that's a 5. 2 45ths, I think I'm doing that right. And a 45th, it's a 1 and 22.5. That's just going to be this side. 4.5%? What do you guys get? 0.04. Give me a couple. Actually, you know what? I'm going to leave it like that. I'm going to leave it. I'm not going to round this off because we're going to add the fractions to get a super precise answer. About 4%-ish?
About
About
4%.
4%. Good. About 4%. Which is also going to be the chance down here, isn't it? So we got about a 3% chance here, about a 4% chance here. Good so far? So that's about 7. That's about 7. That's a combined total of 14 so far. And this is only going to go up by a little bit. So now we've got 5/36. Oh, I think I'm SOL on this one. I don't think I can actually reduce anything because it's 5. Oh well. 5/36 times 5/11. Well, I'm just going to write that as
Yeah, 5 and
5/36
The
times...
30.
Well, that's 36. I just write my
Oh.
crap right now. And I can't divide anything else. I was going to write 5/36 times 5/11 because I can't do it in my head. I don't know what 36 times 11 is. Yeah.
25 over 396.
Oh, thank you. 25 over 396?
25 over 396.
Thank you.
And it makes it 6%.
Oh, that's 6%. Very nice. And this is also right here. 25 out of 396. Which means we've got 3%, 4%, 6%. So that's 3, 4, and 6 is 7, 13-ish. Plus 13 more is 26%. All of a sudden you're like, well, hell, we're doing pretty good. That's 20. We got a 26% overall chance of winning on the points. Not to mention, don't forget that we can also win on the come-out roll, can't we? So all these chances get added together, and that's the chance of us winning overall. Eric, ask me that question. Ask me that question. You're thinking of something right now.
I was just trying to do math
Oh!
in my head.
Well, bless you, sister.
My,
Good, good. So 26% here, right?
yeah.
Over here, 6 and 36 is about 16 more percentage points, yes? That's about 16 more. Good for you. So this is about 16 more. So 16 plus our 26 is now 42%. Good so far? How about what's 2 and 36? That's an 18th. That's like 5%-ish, somewhere a little bit more than 5%.
Almost 6.
Almost 6%. But now the question is, ooh, that's getting awful close to 50-50, isn't it?
It's like
So is that
47.
back to where it was up before?
That's what we need to find out. I've erased it now to make room for this. But I want to know what all these fractions add up to mathematically
Pretty close,
precisely. Right, but close isn't good enough for Vegas. Because if they go over 50%, if that goes over 50, what happens to their money? They start losing on average, which means you start winning. So Vegas needs to make that as close as they can to 50%, but still under. Let's see how they did. And I'm going to pretend that it wasn't added earlier. All right, clear up. I'm going to add all these. So we had a 6 in 36. That was winning on the come out roll of 7. We also had winning on the 11, which was 2 in 36. Now I got to add all these things together. I got a 1 in 36 plus a 2 in 45 plus a 25 out of
396.
396. Oh, I should have done this. No, that's okay. Then I got to do it again, right? 2 in 45. Genius! Genius!
49% off.
Genius. They are going to win on average even a little bit more than we did. They're going to win a smidge more. Now, I'm not saying we weren't winning at that rate. We were winning at that rate. We just only did 190 trials. This is, how many trials is this, technically speaking?
Infinite.
Infinitely many trials, Jacob. Infinitely many trials, right? Infinitely many trials. So, Vegas knows this going in. They know this going in, that if they're going to pay out $1 when you hit that probability, that means you are going to lose your ante the rest of the time, aren't you? Which would be, let's find this math in my head, that's going to be a 5070707 off to infinity. Correct? Does this make sense? You guys buying this? So let's round this off to make it manageable. To find the average, your average winnings, are, that goes so tight, that times that, so we'll call that 1 times 0.49, we'll call it 29, plus the negative, -1 times this 0.5071, which comes up extraordinarily close to the 2 cents. It's just under 2 cents, isn't it? Gesundheit, Gesundheit, Gesundheit. Isn't it just under 2 cents? what was it about negative 1.8 cents, something like that? Maybe 1.9, something like that. My goodness, it's craps allergies. They're contagious. Genius. Genius. Now chew on this. Well, chew on that for a while, first of all. You're losing about a penny, almost 2 pennies every time you play craps on average. So enjoy it, right? Enjoy the game. Go in knowing you're going to lose and don't try to, try to win money on it. You realize you're going to lose money on average. That's the beauty of it, as long as you understand that. But here's the most amazing thing. First of all, before I go to the amazing thing, any questions about this? Please, Jeremiah, go.
I was looking down. How did you get the point 5071?
Oh, I just rounded this off to 0.507 and called that 1.
Oh,
Because these go on forever, these are infinite decimals.
so just the difference.
Exactly, sir. Exactly. I'd have to add up to 100%. Catherine, go.
I was just wondering where you got the 6 divided by 36.
Oh, on the calculator?
Yeah.
Can I erase this? Is that okay? I didn't wait for an answer, I apologize. Which one, Catherine? The very first one?
And the second one.
Tell me.
7-11, right?
Tell me where that 636 came from, friends.
That was
What's the chance of rolling a 7 on the first roll?
Oh, okay.
What's this 2 and 36?
rolling 11.
Rolling an 11 on the first roll. What's this 1 and 36?
Rolling and
Gina's like, I don't know, but it's over there. Rolling a 4, and then rolling a 4 again. Thank you for saying this, Catherine. There are 2 very important words in probability. Some of you are taking 243 eventually, maybe next term. 2 very important words, or and. Now you'll learn this in 243 as well, but this also serves you well in Vegas if you ever go there and want to analyze what the hell's going on. Or always means to add things together, and always means to multiply things. And I found it's genius when you're trying to deconstruct a thing like this to understand the difference between or and this is more of a 243 topic, FYI, those of you taking 243. But in order to win on a pass line bet, you either have to roll a 7 in the beginning, or roll an 11 in the beginning, or roll a 4 and then roll a 4 again. Remember those multiplication in there? Or roll a 5 and then a 5 again, or a 6 then a 6 again, or an 8 then an 8 again, or I lost track of where I am now. But you see how the ors and the ands are in there? It's a 243 skill, but you just kind of got like an introduction to it today. Jeremiah, does that make sense? You buying that? Excellent. Now, wrap your mind around this, not too much because your exam actually deals with this. You can bet against the roller. This is a pass line bet, right? This is a pass line bet, which means the roller wants to get a 7 or an 11 on the first roll, and then he or she wants to match their point if they don't. You can bet against that person. And you can say, roll snake eyes, roll 3, roll 12 on the first. And then, oh crap, they didn't. But they didn't roll a 7 or 11. Yes! Oh, they rolled a 4, roll a 7! You see what you're doing? You're essentially betting against the person. Well, that can't work, can it, for Vegas?
No,
That can't work. Why?
because they're always most likely going to lose, so if you bet against them, you're always going to win.
Crap, I erased it. This would be the chance of that person winning, wouldn't it?
Right.
Loss becomes win, win becomes loss.
Yeah.
So, one of your exam questions asks you to do a little online research and figure out how they adjust that bet. Because it's not exactly the opposite of a pass line bet. There's one little teeny tiny difference. That one little teeny tiny difference. And that little teeny tiny difference makes all the difference from an actuarial point of view. And when I say actuarial, I mean the people in the back keeping track of the money coming in. Because if they didn't keep track of that, the money would stop coming in and start going out into the gambler's hands. And this happens every like 10 or 15 years. Can I tell you guys a story about the kids in New York?
Yeah.
Yeah, every 10 or 20 years, somebody screws up because the actuaries are falling asleep behind the wheel. Double the payouts. If you're paying attention, you make a lot of money really quickly. Really quickly. But it doesn't happen that often because people are getting smarter about statistics, I think. But until they do, take full advantage of their stupidity. Yes. I'm kidding, I didn't say that. Crap, it's recording. It's all good. There you go. There's craps. That's how you analyze, actually, that's how you analyze any casino game. That's just craps in a nutshell. And that is what we call Math 105. Hell yeah. That's all we got. Hell yeah. Back to you guys. To you guys. Yes, that was fantastic. I learned a buttload from you guys today. Buttload. Mathematical. Mathematically measurable amount. Quantifiable. Please, Kathy. Question 5. Oh, what was question 5?
49.
Oh, we just did it. It's 49.29%. If you want to round it off to 2 decimals. Please! Well, technically you can't because you weren't part of the original data collection.
I know, but I can't remember.
But you can't though. You have to actually gamble to get the data. Plus you change our data. It's okay. You got plenty of quizzes. You don't need it.
Oh, yeah.
All right, that's all I got. Make a pile if you did it. Thank you for the data. Email me if you get stuck. We'll catch you on Wednesday. Yes. It won't show on there. It'll show at the bottom of the report in the rainy day exam section. I can't make it simple. I could. I want to keep the original grade in Excel and then add the something else.
You ready for this?
Report and see if I
So this is just for the right answer.
You need to the instructions say you have to add all the elements. Not just as possible. Look at the right above the question. List every possible.
Yeah.
If you're not going to figure agencies, don't just give them three answers. You have to actually have them all written down, like this. Perfect. Well, you can to get that number, and sometimes the numbers all matter, like for this, we can actually have all 36 answers fine. But when you're learning how to count like that, I don't want you to have that. Fair? Yep. Excellent. Don't pass that. Oh, yes. You got time right now? I can show you. Let's get this question answered. I'll do it for you. Sure. I don't know what you said. It was Tuesday, I didn't get it. I'll get it today. But I will, as soon as I get it, I'll respond back. It was about. Oh, I didn't get that yet. I'll fix it. Don't you worry. Huh?
That's lower than a 10, or if you did bad on one, you could redo it and then resubmit it.
It is. Well, it's the email.
Minus 5 points. You could turn that in and resubmit it. That's if you let them do it right.
Let me come back. I don't today. Just fold the corner down. Yeah.